Hello, gentlemen. This video is going to just continue on what we did in the last one, which was using our fundamental identities to show expressions, to simplify expressions. Should be a quick video. We're just going to go through a couple slides of examples just to make sure that you guys understand this again, because what we're going to want to do in the end is really solving these trig equations, and we're going to use these fundamental identities, and we have to know them and use them well in order to be successful solving those types of equations. So let's get started. Here's a little different one here. We've got 1 minus cosine squared x plus cosine to the fourth of x. If you look carefully at this, and again, it looks something like, if I gave you something, let me get my pen here. If I gave you something like this, 1 minus 2x squared plus x to the fourth, you should recognize that I can factor this, okay? And that's the same thing here. If you think about cosine squared of x as x squared here, we can factor here, okay? This can be 1 minus x squared like that, squared, because then I get 1 minus 2x squared plus x to the fourth. So I can do the same thing right here. So let's factor. I got 1 minus cosine squared of x, all squared. I should recognize this part right here as a Pythagorean identity, okay? Remember that sine squared plus cosine squared is equal to 1. So 1 minus cosine squared is equal to sine squared. And so I got sine squared squared. Again, exponent to an exponent. We multiply. So I get sine to the fourth of x. This one's a little bit different here. We're gonna do some factoring by grouping here, which is actually gonna be helpful. Let's look at the first two terms. Let's look at these two and factor out a secant squared. Okay? And then I'm going to factor out negative 1 on this side. So if I take out a secant squared, I'm left with secant x plus 1. That's these first two terms. These two right there. Go right there. Factored out a negative 1, so this became secant x minus 1. Now if you look here, I have two. I can factor again. I can factor out a secant x minus 1. So let's do that. Then I get a secant squared minus 1 times secant x minus 1. Okay? Again, I factored this term out of each term right there. I'm left with secant squared x minus 1. This here, again, going back to some of our Pythagorean identities, remember 1 plus tangent squared of x is equal to secant squared of x. So this term right here, if I just brought that 1 over, that's going to give me tangent squared right there. Okay, so I get tan squared times secant squared minus 1. In this particular example, I would start by, it doesn't look anything obvious jumps out at me right off the bat. So what I would do here is I would just start to simplify this expression by getting a common denominator. Common denominator here is 1 over secant x plus 1, secant x minus 1. If I do that, I got to multiply. If I have 1 over secant x plus 1, that first term I got to multiply top and bottom by secant x minus 1 over secant x minus 1. Then I got to do the same thing on this side except with plus 1. Minus 1 times secant x plus 1 over secant x plus 1 like that. This term over here becomes secant x minus 1 from this term plus, sorry, it's got to be minus because that's a minus there. Minus, I'm sorry. Secant x plus 1 all over the common denominator, which is secant x minus 1 secant x plus 1. And what you're going to notice is the secant x's are going to cancel, and I'm going to be left with negative 2 on the top. So let's do that through. Okay, if I simplify, that's the first term right here. That is there. And this part is right there. Okay? Secant x's are going to cancel. I'm going to get negative 2 on the top. Okay, like that. Negative 2 over tan squared. I can use the fact that 1 over tan is equal to cotan, so I'll get negative 2 cotangent squared of x. All right. Tangent minus secant squared tan. Again, let's start by getting the common denominator, which is just going to be tan x. So I'm going to get tan squared of x minus secant squared of x all over tan of x, like that. Again, this is a negative, is another identity. So remember that we had 1 plus tangent squared of x is equal to secant squared of x. If I bring the secant here and I bring the 1 over there, I'm going to get tan squared minus secant squared of x is equal to negative 1. So I'm going to replace this part right here with negative 1, and then 1 over tangent is equal to cotangent, so this is going to be negative cotangent of x. 5 over tan x plus secant x. If we look here, we're going to use it. We're going to multiply by. We want to use this idea again. So if I multiply top and bottom by tan x minus secant x, what I'm going to get on the bottom is again a tan squared minus secant squared. We just did that out. So this bottom term right here is going to be negative 1. So if I can simplify that, negative 1, and then I can bring that negative up, this whole denominator goes away. So this negative 5 tan x minus secant x. 3 minus 3 sine x, 3 plus 3 sine x. My first instinct here would be to FOIL this out. I will get 9 minus 9 sine squared x. I'd factor out a 9. 1 minus sine squared of x. We know this. 1 minus sine squared of x is simply equal to cosine squared of x. So I got 9 cosine squared of x. Let's do one more. Again, I would use the same strategy that I did before. Let's FOIL that out. I got cotangent squared x minus cosecant squared of x. That's similar to this. It's the same idea. It's just with cotangents and cosecants. And so what we should see is that that is equal to negative 1, along the same reasoning, because I would use 1 plus cotangent squared of x is equal to cosecant squared of x, like that. And then what I did is I bring the cosecant over, so I get cotangent squared of x minus cosecant squared of x, bring the 1 to the other side, and I get negative 1. Okay? Here's some more practice, some more examples to look at. A lot of examples here. Fellas, this stuff is really important, so make sure you're taking the time to understand the process that you need to go through to verify these and simplify these expressions. Make sure you're emailing me if you have any questions, and then we'll just go from there. Okay, we're going to move on and start showing some identities, which again is going to utilize these trigonometric identities, so we have to make sure that we understand how to use them. Okay, have a good day, fellas.